I'm about done monkeying around with these LED lights that I got from Electronic Gold Mine. Right now, Electronic Gold Mine is selling one of these boards for $12. I bought 5 of them for $20 when they had them on sale. So I reckon if you wait a while and you want some, they'll have them. There are 12 RGB LEDs on these boards, a voltage regulator, and 2 connectors. This connector is for the input, and all you really need is clock and data and a latch. So it takes 3 pins to get these things to work. This is for daisy chaining, this connector over here. And you hook them up one-to-one, this connector to this connector on the second board, and then this connector to this connector. I've got 3 daisy chained. I have 5 boards, and out of the 5 boards, these 2 have a problem which I haven't investigated thoroughly, but the lights light, but they're not consistent as to what colors they are, and I don't think the shift registers are working just right. There are 3 shift registers on each board, so there are 16-bit shift registers, so you're talking about shifting through 9 of these things to get 3 boards done. I use the regulator on each board, so I input on the 7 to 18 volt line. It's on the schematic, so you can figure out how you're going to do that. The schematic is pretty thorough. There's a couple of capacitors missing that are not really necessary. They're just decoupling capacitors, and if you want to know what they are, you can sort them out. The output on this number 2 connector is buffered with these transistors here, so the drive is good enough to daisy chain through, and the timing seems to be good. It's not at all critical about how many boards you've got hooked up. I've got several tests going, and you can see my boards are daisy chained. That's the last board. This is the middle board. See the output here going to the input of that one, and the input of this one coming from the output of the first one, and of course the input to the first one is going to my development board, which is a V7. I'm using a 45K22, which is plenty of resource for this sort of thing. The software is done in MicroBasic, and it's really not a lot of software. I rather bludgeoned it, but it's taken right now 5,600 bytes of ROM and 68 bytes of RAM. So it's not, I've got it in 2 files, and this will all be down as version 3. I'll upload the final version as version 3, and you can see how this works. Now I've hooked it up so that the tests are run via the E.0 button and the E.1 button. And as a general rule, the E.1 button will start the test over or change the color depending on what test you've got. The E.1 button will advance to the next test. This is the absolute worst case. This is all white on all 3 boards, and I put the color up on the display. But I don't know if you can see it, but it's at 0.79 amps to drive 12 times 3 LEDs, and you can see they're pretty darn bright. That's a fairly efficient little LED, and of course to get white you turn on the red, blue, and green. All right, and with the E1 button or E0 button, you can advance through the colors, and I've done yellow and cyan, which is my favorite color, by the way, green, magenta, and magenta is not perfect because it's the 2 outside LEDs. It's the red and the blue, and the yellow is in the middle, so you can it doesn't actually blend as well as the other colors. Red, which is bright red. Notice on the schematic that the current limiting resistor for red is about 3 times higher than the current limiting resistor for the blue and the green, which makes sense. The red is a brighter color. And then straight blue and off. So you've got those colors, and that's all you can mix. There is no partial mix, so that's the whole gambit of it. And then if I push E1, I'll advance to the next test, which flashes them. And I put these two things in there because if a board isn't working, these are the two tests that you would really want to use to know if everything is working. In order to flash these things, I turn them all on, and then I load up the shift registers with off, and then turn them back on, so it's constantly shifting through the shift registers. But you don't see it shifting through because nothing shows up on the LEDs until you assert the latch line. The next test is a slow running color sample, so it's cycling through all the colors, going through all the boards, and just rotating them, which really amounts to shifting the next color into this LED. All the others will shift down. So that was fairly easy software. Then I've got a medium speed. I don't know, I'll hold these up so you can see them shifting through. And you can see it's kind of interesting when they're all three going. And then the next one is a fast speed, which is more of a bijou look, if you will. My wife calls it the bijou look. And to do this, it's only taken 470 milliamps, which again, I think is fairly efficient given all the LEDs and all the brightness you're getting out of it. The next test is chasing one color. So I will chase the colors sequentially from one board to the next, just right to left, shifting them through, which is yeah, kind of interesting. I don't know that it's of any value other than for the looks. The next test, I've added a few tests since Rev 2. Now I've got chevrons running up, and there's two, one on each side. And if you use your imagination a little bit, you can see the chevrons. There you go. And they run up off the top of the board, up from the bottom of the board, alternating right to left. And if there again, the 0 button will change the color. So you can step through all the colors, and that's just a matter of what binary code you send the board. The next test is what I call turning left, and it is very much like a turn signal. I'll line the LEDs up a little bit, and you can see a turn signal going. Now this one was quite easy. Once you set it up initially, you just shift in a blank and everything moves to the left. The next one wasn't quite as easy, turning right, because now you're moving it the other way, and I can't shift in from this end, so you have to reset everyone, and this ended up a little bludgeony because I was getting tired of fussing with it, frankly. So I did a huge case statement and just set the data. There you can see it, shifting through. I'm not sure what good these things are, other than the fact that they would work in a gaming machine, like Khomeini intended. You know, their attention, it would be an attention getter. Then you're back to the beginning, all one color white. And that's pretty much the story on this thing. I'll put up Rev 3, and that's the end. I'm not gonna fuss with it anymore. But you see, you get a lot of light out of this guy for 700 or 800 milliamps. I thought it was a pretty good. There, that's the one I like the best. You can stack these up. You can see this is truly an attention getter. This guy. And they're bright. And I tell you, you could dress up the underside of your car if you lived in East LA or something. So, there you are. That's the whole deal. It's easy to interface. The software is not particularly hard to write. And they work. They're efficient little RGB LEDs. And that'll cut it off from here. So thanks for looking, guys. Later.